This is Unit 3, Video 9. In this last unit, we will talk about chemical formulas and names. Now, we'll actually do this for compounds. So, most of the elements actually exist in compounds. They don't exist elementally, like we find them on the periodic table. Most of them react. And remember, compounds are elements, two or more elements chemically bonded, chemically combined. So, two or more elements chemically bonded, or you can say chemically combined. So a chemical reaction must happen for them to combine together, and that's the ones we'll look at. We're actually going to be looking at ionic compounds. Now, ionic compounds are compounds made of ions, specifically positive cations and negative anions, and they are formed by a transfer of electrons from the metal to a nonmetal. So we've seen this picture on the previous video, and this is what happens. The sodium is a metal. Sodium gives up an electron to chlorine, which is a nonmetal. Chlorine accepts the electrons. When this happens, you form two ions, the sodium positive ion, the chloride minus ion. And these will usually, ionic compounds will usually contain a metal and a nonmetal. In our cases, they will always contain metals and nonmetals. Now, atoms from the S and P block will form just one type of ion. Remember, the S and the P block are on the left and on the right of the periodic table. And we've seen how to get these positive and negative ions by using the noble gases. So, for example, group 1 always forms positive 1, group 2 positive 2, group 3A plus 3, group 4A can either go either way. But if you take a look at carbon, carbon is 4 steps away from neon, which means it can gain 4 electrons for negative 4 charge. It's also 4 steps away from helium, so you can also lose 4 electrons to become a plus 4 charge. That's why it's plus or minus 4 for this one. And then these guys are minus 3, minus 2, minus 1, and obviously noble gases don't have a charge because they don't react. We'll use these charges if we're looking at an S and P element. You can know these just directly by looking at the periodic table. Now, what about the D elements? It turns out the D elements you cannot know just by looking at the periodic table, because D elements will form more than one type of ion. An example of it is iron. If you take a look at iron, iron forms two types of ions. It forms a plus 3 ion, and it forms a plus 2 ion. And the plus 2 ion forms a compound that's black. This is iron 2 oxide. Plus 3 forms a red compound, iron 3 oxide. So there are two forms of elements usually from the D block. So we just by looking, we cannot know. Now you're asking, well, how will we know? And we'll give you a clue about them through the name itself. So we'll show you how to find out which one it is. Now, ionic compounds will form so that the positive and the negative charges cancel each other out. And this is to form what are called neutral compounds. So you can't have any charges in a compound. The charges are essentially hidden inside. So for sodium and chlorine that we've seen earlier, called sodium chloride, the metal will have a plus 1 charge. The nonmetal, we said, has a minus 1 charge. So what happens, the two come together to make NaCl. And the charges are hidden inside. This is plus 1, this is minus 1. Notice they both match each other up, and the whole compound is neutral. And the formula, or the picture, if you were to draw them out, you'll actually see a ratio of 1 chlorine for 1 sodium in the compound itself. And this is a crystal form of sodium chloride. So let's go ahead and do some examples writing ionic compounds. Let's write an ionic compound made up of magnesium and chlorine. Now the first thing to do is to look at magnesium on the periodic table and find its charge. Magnesium is in group 2, so it'll have a plus 2 charge. So look up on your periodic table, make sure you see how we got that. Chlorine, we've just seen chlorine, has a minus 1 charge because it wants to be like argon on the periodic table. Now the question is this: how many chlorines do I need for how many magnesiums so that I form a neutral compound? Remember, compounds are neutral. I want to get down to being neutral. And what I want is 2 chlorines for every 1 magnesium. And that's the answer, because if I have 2 chlorines, that gives me a minus 2 charge, which now balances the plus 2 charge on the side of the magnesium. So my compound is actually magnesium with 2 chlorines. The number at the bottom is called a subscript. And this subscript tells you how many of the atoms you need. So you need 2 chlorine atoms for one magnesium atom. In fact, it's 2 chlorine ions now for 1 magnesium ion, and this is the formula. Let's also do one between aluminum and oxygen. If you do the same thing, find aluminum on the periodic table, you'll see a +3 charge on it, and find oxygen, you'll see a -2 charge. Now the question is, how do we make these equal? Well, let's get them both up to 6, and it's actually a common multiple of 3 and 2 to get you 6. So I'll have a +6 on this side, I'll have a -6 on this side. To get there, I'll need 2 aluminums, and I will need 3 oxygens. And that gets me the balanced out charges. So my formula is actually Al2O3. This is the final answer. Again, you need 2 aluminum ions for 3 oxygen ions to form this compound. Go ahead and do problem 11 on your own. Write the compounds between sodium oxygen and calcium and nitrogen. Do the same thing. And then we'll finish up with let's do the same thing backwards. So it says indicate the charge on each of these compounds, on the ions of each of these compounds. So let's do the same thing but backwards. So what I'm going to do is essentially break apart chromium and chlorine into its elements. Here's chromium and here's chlorine. And I'm going to ask what's the charge on each. Now I know that the charge on chlorine is -1. That's given from the periodic table. But the chromium I don't know, because chromium comes from the D block. We said D block elements have more than one type of charge. So I'm about to show you how to find out what the charge is from the D block. What you do is you realize you have 3 chlorines. So since we have 3 chlorines and each chlorine is a -1 charge, to balance the total charge, which is -3, chromium must be a +3 charge. And that is essentially the answer. So the answer for this question is right here, +3 and -1. Let's do the same thing for copper and oxygen. In this case, we have 1 oxygen and 2 coppers balancing it. So the oxygen we know from the periodic table has a -2 charge. The question is, what must each copper be? So together they balance out the -2. And the answer, since both of them must be +2, each one then must be +1. So the answer here is actually copper +1 and oxygen -2. So notice what we've done is we essentially undid the ions to show the specific charges on each of them. So what we'll do now is we'll finish by naming ionic compounds. We'll show you how to name these. And the rules are as follows. The S and P block cations, there's actually no change to the name. And so potassium, for example, you simply will say potassium, nothing extra to add. If you come from the D block, if the metal comes from the D block, you do the same thing, except then you use a Roman numeral to indicate the charge. So iron, for example, you'll say iron, but then you'll put 3 in parentheses, indicating the charge using Roman numerals. That's the first part of the ionic compound. The second part, the anion, the back part, you'll name by dropping the ending and adding "-ide", the suffix "-ide". And "-ide" indicates you have a compound. So chlorine, for example, is named chloride. And that's why sodium chloride is named sodium. The first part doesn't change. Chlorine changes to "-ide". So we're going to do some example problems of these and finish up. So here it says name these ionic compounds. Alright, find barium on the periodic table, or find Ba, which is barium. So we'll just call this barium. The first element does not change. Barium. The second element is sulfur, and the ending changes to "-ide. So you'll do sulfide. So you have barium sulfide for that compound. Let's do the same thing with MgF2. So Mg is magnesium. And then fluorine becomes, you guessed it, fluoride. And there it is. Copper, or Cu, Cl2, is copper chloride. So let's put copper. And then for chlorine, we'll put chloride. And then nickel 2O. Nickel is the same as before. Nickel, and oxygen gets oxide. The ending becomes "-ide". Now you'll notice that I left a little bit of a gap here for both nickel and copper. The reason for this is because both nickel and copper come from the D block. These guys are for the D block. So the rules say I actually have to put a Roman numeral in for them. So both of these will actually have a Roman numeral. The question is, what is the Roman numeral? And the Roman numeral comes from the charge. what I have to do is I have to remember how I undid the charge. I have to find the charge of copper. I have to find the charge of nickel. Now for copper, what I can do is I realize I have one copper again with two chlorines. I know each chlorine is a -1, so that means the -2 must be balanced by a +2. And this +2 is what goes in the Roman numeral. So this is copper 2 chloride. Do the same thing with nickel. There are 2 nickels in this case for every 1 oxygen. I know oxygen is a -2 charge. So what must each nickel be to balance out the -2? We know that together they must be +2 to balance out, which means each nickel is a +1 charge. So this is nickel 1 oxide. So we went kind of quickly through that. Hopefully that makes sense. We'll practice these also in class to make sure you understand them. And that wraps up for us the lesson and the chapter.